Our first speaker today is Julius Van Der Werf. Julius completed his studies at Wageningen University in the Netherlands and also studied in Cornell in New York. He's previously held positions as associate professors and senior research scientists in dairy before moving to sunny Armidale in 1997. He is now a professor in animal breeding and genetics at UNE and is also head of school. Julius has supervised more than 60 PhD students, so he's very engaged with students and young researchers, and he's also led many research developments in sheep genetics over the years, including the genomic selection, which continues to be a key area of focus of improvement in which you'll hear Julius talk about in his presentation today. So please welcome Julius to the stage.
Thank you, Clara. Does it work? Yes, it works. So I'm going to talk about resource flocks, just reflecting a bit what it has meant, but much more importantly, what we're doing next. And as you see, the resource flock, as Steve also mentioned, has been the engine of genomic selection in sheep in Australia. It has been very important. So we have to see why it was important and what it can do in the next 10 years. So I've worked a lot with Sam and Daniel, so they acknowledged their co-authorship. So other than Steve, what I learned from Steve and what we all saw from Steve is what we have all achieved. Also, Peter referred to that. And I was thinking, you guys are all an amazing bunch, because if I present something about sheep on a world stage, it's amazing what we have achieved in Australia, I think. For an extensive industry that's a bit low cost and you don't spend too much per animal, unlike dairy cattle. We've introduced a technology which works amazingly well, and we have worked on genetic gain, which has also worked amazingly well, which is almost comparable with the dairy industry. And that's quite unique in the world. So well done, everyone. I think you can all have a pat on the back. The other thing from the previous speakers, what I learned from Alan, is that there's three things important to move forward in a successful way. One is we have to cooperate, and that's going to be very relevant to the Resource Flock project. The other is that we have to look for change, and there was a third one that I forgot. But you can put it in the question. Okay, how do I change this? Okay, so I'm going to talk about the resource flock and what it means for our genetic progress and our breeding programs. And of course, the key word first is genomic selection, because we've started them so we could do genomic selection, and as I said, that has worked very well. But also, you have to realize in sheep, genomic selection has meant very different things than in dairy. Dairy industry was the first industry to take up genomic selection, and it makes a lot of sense to do it in the dairy industry, because bull selection is the most important selection to make genetic progress. It determines 80% of the progress, but you can't milk a bull. So typically in dairy, everything is a hard to measure trait, and you can only measure it on females. So genomic selection in the dairy industry meant that they could actually select bulls at 2 years of age rather than 7 years of age, and therefore make a lot more progress. So that's not so much the case in sheep, because in sheep a lot of stuff can be measured on males as well, other than reproductive traits. But in sheep we have not so much made more gain for the same traits. We have a lot more focused on new traits that were important, but we couldn't change them before. So that's why the breeding objective and where we go next is very important for looking at what do we want to achieve as the resource flock. So there's a lot of emphasis on new traits, and we have to keep looking for them. So before genomics, breeding and genetic improvement was based on selection. And the best thing is to measure an animal for what you want, because then you can improve the population. But we can't always measure the animals, so sometimes we use information on relatives. And always, if you use information on relatives, you do a better job. So relatives are related to you that you want to select because their DNA is similar. So that helps, and that gives some genetic progress for things that you can measure in your flock. So after genomics, we did this. We created a resource flock, which was measure a whole bunch of animals and DNA test them, and then we still look at relationships, but now we look at a DNA level at relationships, And everyone that's a bit similar to you tells you what you will perform as breeding value. So, and the power here is that we can actually measure animals that are much more distantly related to you, and we can measure animals that, for new traits that are quite far removed from your flock, which is then the resource flock. So we have a lot of slaughter animals, we measure slaughter traits, and that informs the young rams that we want to select. So, so it's good to understand the purpose of the resource flock in a breeding program. It's really new information, and as Steve alerted to already, that we always need information for genomics. Without information and phenotypes, we can't do genomic selection. The difference with genomic selection is you can now use a lot of different animals, and many of them, to predict breeding value. So in summary, what genomics has done to us, you can now measure much more new animals for new traits, and in particular we call them hard to measure traits. So we've emphasized a lot the meat eating quality traits and the carcass traits, and that has been a big success, as we saw already. We have changed genetic trends, we have EBVs for them. We can do a lot more than we could 10 years ago. And we can also do much better in reproductive performance, and that's a really important economic trait as well. And we've started to get good EBVs for it, and we've started to get good resource flock data for it, but that we need quite a lot more to do better. But already we should see more improvement for reproductive traits compared to what we could do a decade ago. Other things that are hard to measure are things like parasites, lifetime wool, and we have also methane and feed efficiency as a new trait that we want to look at. So a bit more about that later, and much more about that tomorrow when Daniel talks about it. A bit of the history of the resource flock. So we started actually with the sheep CRC in 2007, which we called the information nucleus. That was a word, I think, coined by Rob Banks and other people that had a beer together. And what we did in the sheep CRC time in 5 years was to have 18,000 lambs born. 10,000 of those were slaughtered and measured for carcass traits and eating quality traits, and 4,000 were measured for reproduction traits and wool traits. So in first instance, that was an amazing data set to estimate genetic parameters, because we didn't actually know very much about intramuscular fat, shear force, and how that was correlated to growth. But we very quickly saw that it was correlated in the wrong way. If you select very hard for growth, you actually decrease eating quality. So the first outcome of the information nucleus was that we had to do something about eating quality traits. The other good thing is we genotyped all those animals, and we realized that that information could help predict breeding values for those difficult to measure traits. So after the CRC, or during the CRC, but taken over from the CRC, was the MLA Resource Flock in 2012, where we basically measured 12,000, well, in 6 years' time, we measured 12,000 lambs for just meat eating quality. We didn't do the wool anymore, we didn't do the reproduction anymore. So that project finished in 2018, and because it was delivering good results, MLA decided to keep funding the project, and now we're in this third phase, which is basically the MLA Resource Flock version 2. So we still kill about 2,000 lambs per year on research flocks, but what we've added to it is also use commercial producers' data to add extra data to the flock, because if people measure those traits, why not help them and genotype them so we have more reference population. And importantly, reproduction, we also needed information on reproduction to do genomic selection, but reproduction is a trait that is already measured. The problem is that we need genotypes on those animals that are measured, so the strategy was to help breeders that measure good reproduction data to genotype their animals, so we had also a resource flock for reproduction. And the idea is to collect data on at least 12,000 ewes in 5 years, so we're well on the way then. As you know, probably the AWI has also an MLP project, and they measure reproduction as well, and wool traits, of course, and in a way that's also a resource flock or a reference population for genomics. So if you're not so familiar with it, in the resource flock, we typically have 35% pure merinos, and that slowly maybe decreases a bit to 30%. But the rest of the animals that we measure are all crossbreds. So it's terminals times merino, or terminals times first cross use, or maternals times merino. There's a lot of numbers on this slide, but that gives a bit of a trend over time of what kind of rams we have used. This goes back to 15. I could go back all the way to 2007, but that's too far. So of the terminals, which is in pink, the top one, we used to mostly do white Suffolks and Poll Dorsets, but slowly we've also more and more measured the smaller breeds that were still important, but they had to build up a reference as well. So we, from as you can see, from a lot of Poll Dorset and white Suffolk in the beginning, we do now a lot more Texel and Suffolk as well. Because otherwise you wouldn't get data for those breeds. So in the maternal block, it used to be mostly Border Leicester and maternal composites, but now it's less Border Leicester, more maternal composites, and a few of the other two smaller breeds. And we still do quite a few merinos, although mostly the dual purpose, and Sams sometimes if they come up with sires, and the Doonies have also been important. And I should also say the Dorpers that were not measured originally, we do quite a few Dorpers every year as well. So this shows how many animals we have measured in the Resource Flock projects over time. So the top bit is the CRC. So we only had animals on resource flocks, like actually we had 8 flocks across Australia, mostly from research institutes or universities. So that's those 10,000 that I talked about. The second Resource Flock project was expanded because we started to measure more lambs from commercial animals. So that there's a bit of overlap between those projects, but and this is Tom Bools mostly, I think. He was one of the first to say, look, I'm slaughtering lots of lambs, can you help me and genotype them? And that's now a regular thing, so we call those the satellite flocks. So every year we slaughter about 1,500 or up to 50. I think the program says 600, but it goes a bit up and down. But overall, that will be 10,000 of what we call satellite flocks. So those are commercial lambs that are produced by breeders that mate their rams maybe to merinos or to whatever ewe they have. And they want to progeny test their sires, and they collect their data, and we help them slaughter it, pay a bit for it. But it's typically a co-investment. Oops. So that co-investment that we're doing here is important because that's going to be more and more the model of the future, where breeders want to have data, the industry wants to have data, we have to work together to collect it together. But this green bit is mostly still funded by MLA. I'll show you a bit more about it in a sec. So what we have started last year is a new project on methane, because as you know, everybody worries about methane and climate change, and we are obligated to the consumer and the public to look at what we can do in sheep, and we can actually select for methane efficiency. So Daniel will talk about it tomorrow, but methane and what you eat is very related, so we also are interested in genetic variation and feed intake. So those two traits are a separate project, but because we have that resource flock set up already, where we genotype lots of animals, if we measure the same animals for methane and feed efficiency, and we measure them for the eating quality and the carcass traits and their growth traits, we have a lot together, and we can also look how those traits are correlated to each other. So this is a slide from Andrew Swan many years ago, and the idea was that breeders collect lots of data, and that data goes over the internet to sheep genetics, so those are the internet pipes. Then Eggbook calculates breeding values to put it through their machine, and then sheep genetics produces ASBVs back to the breeder. So this concept works very well in Australia due to you guys doing such a good job. But if we measure new traits, like meat traits or methane traits or feed intake traits, they can all go in that same pipeline. So we have already a model to calculate breeding values. We just need to put in the data in the database, and then we have EBVs for those new traits. So the good thing is that when we do new measurements, it can very quickly turn into something that you can use for selection decisions. So other than methane and feed intake, in AgBu they do a lot of index work, and what Andrew talked about, like what is the next thing we have to worry about. So health traits, resilience traits, traits around maternal behavior and lambing ease, they're going to be more and more important. You have told sheep genetics they're important, and we don't have a lot of information about those traits because they're not always that well measured. So we're looking for either breeders that measure them well, or we can measure them in the resource flock well, such that we can also predict breeding values for those new traits and therefore improve them. So in general, I use the word resilience traits. I think this conference has a bit the resilience as a keyword, so you talk more about it tomorrow. But the point is that if traits are important and we measure them in a reference population or in a resource flock, we can actually improve them. And we can use genomics to help, but we can also use other information. So let's look why the resource flock is important. Well, in first instance, it's because we can now do genomic selection of young breeding stock early on without having to wait for those animals to have phenotypes on those traits. So we can also use genomics to predict breeding values of animals that do not measure so much, so like at multiplier level. And that's actually quite important for the industry to have a quicker rate of improvement down the pyramid of the population. We can also predict commercial animals' breeding values with genomics, and that's very important. And some of you might think, well, that's maybe a bit unfair because we've been measuring traits for 20 years and have EBVs, and those guys can do a DNA test to select animals. Well, I think there's two things important. One is a DNA test alone is never as accurate as having a lot more traits around it. And also, the more what's in the reference of your own type of animal, so the closer you are related to the reference, and you can be related by having, say, sires in the resource flock, the better that genomic information helps you. But the important thing is that if commercial people use breeding values, they become breeding value savvy. They're becoming interested in improvement because it's like what the flock profile did. If people realize how good they are genetically, they're going to look for ram sources to become better next year. I think we all have that a bit. Like I'm doing the park runs on Saturday, and I don't like running, but because I get a time, I want to have a better time next week because I've recorded what I did. And so I think information is always helpful in improvement. And if the commercial people have more knowledge of the genetic merit of their stock, they will want to buy the better rams that are around. So that helps to everybody using EBVs and everybody making genetic improvement. So you can imagine that commercial producers could use genomic predictions for replacement of ewes in lamb supply chains, like those supply chains could demand certain genomic tests to make sure that they use the right lambs for their production systems. It's a bit similar to the cattle in the feedlot. You only invest in animals that can do what they are supposed to do, and if you can select the bad ones out, that would be very profitable. But in that system, we also want to predict crossbreds. Like a lot of commercial people buy crossbred ewes. How can we predict those breeding values? We need a resource flock that compares merinos and maternals and crossbreds to see how they compare to each other. So the world in genetic improvement will more and more rely on genomics. Genomics will become cheaper and cheaper over time. Like if everybody uses genomics, the test will go down in cost because we do then not 100,000 per year, but 1 million per year, or maybe 5 million per year. And so that all creates information that we can use. So to be ready for that time, we need to expand the resource flock concept to help predict breeding values of commercial animals as well. So there's a lot of other advantages of the resource flock in general, but also to be part of the resource flock. One is that you can progeny test your sires. You get a lot more information of the sires that are being put in. Also, you can link the flocks much better together because there's this central resource that compares genetics with each other, and that helps everybody to be better compared to each other. Of course, if you have new traits and you have a central source where you measure that, such as methane and feed efficiency, we can estimate those parameters and we can see how those are correlated to growth, to reproduction, and so on. And the resource flock has been used a lot for overlay projects, a lot of them related to slaughter and slaughter methods and measuring things on carcasses, and Peter's going to talk about it later today. We use resource flock animals because we know who they are. We've measured a lot of other things, and therefore they're handy resources to measure more things about what we want to know. So the question about who benefits from the resource flock, it's a bit the whole industry, of course, but it's also individuals that help co-invest in it. Just to illustrate that, this is a picture that Daniel made. If you look at the EBVs of different traits, and so those funny figures are such that that's the lowest ASBV and that's the highest, and the thicker the curve, the more animals there are at that level. So there's a few very top ones and a few bottom ones. And those are ASBVs of animals that had progeny in the resource flock. And if they didn't have progeny, so we took the data out of those to see how the EBVs would change, or the ASBVs. And what you see, especially for things like IMF, those top ones that you know now a lot of information about, and the bottom ones, you would never know, you would never pick them up without that progeny because they're all more around the average. So you get more spread in breeding values, and it's easier to pick out the top ones if you have more information. And this is due to having progeny in the resource flock. And similar, this is the accuracy of those breeding values. So again, this is IMF. Accuracies could be quite low if you don't have data in the resource flock, but if you did have data in the resource flock, they will always be very high. So this lean meat yield, this is shear force. So especially those hard to measure traits that you wouldn't have a lot of information about, you increase overall your accuracy of your sires a lot more if you have them in the resource flock. So just where are we going with the resource flock model? And that's not only what we're going to measure, but also how we're going to fund for it, because MLA spends quite a lot of money every year on the project. And the question is, how can we go forward in the future? And as I said, the current resource flock project already combines a bit investment from individuals that want to have data about their animals and investment from MLA that invests in the industry. And that concept we want to clarify a bit more and also utilize a bit more. So currently the core resource flock project, which is at Kirby, Katanning, and a small one at Temora, we made about 2,400 ewes with AI. We use 150 sires every year to do that. So those are basically research flocks where we measure lots of things like monthly growth, parasites, lots of live traits, and of course all the carcass traits. So we produce about 2,000 lambs a year, about 13 progeny per sire. So if you put a sire in, you get data on growth, methane and feed intake. That's only recent, of course. Eating quality, and those progeny are genotyped as well. So that investment is mostly MLA. And of the total resource flock project, that's 83% of the budget. But as I said, we also work with with breeders that have commercial slaughters. So we call those the satellite flocks. And so lots of sires are mated to, so some breeders mate their sires to certain sets of ewes. And we work with them. We pay half of the slaughter costs, which is about $150 a lamb. So that's not just slaughtering the animal, but it's measuring all this IMF and shear force and so on. And we genotype the animal. So for those animals, MLA invests about 60%, and the breeders invest about 40%. Of the full budget, it's about 12% of the whole project. And we work with breeder flocks that measure reproduction. So there, the breeder invests everything in phenotypes because they measure reproduction anyway. All we do is we help them with genotyping animals. And there, the breeder actually invests more than 2/3 in that data. But that's only a small part of the full cost, but this is all about reproduction. So you see we have now a model where for some MLA pays everything, for some it's a co-investment, and for some we rely a lot on what the breeder does. So this is referring to cooperation. So we need to levy funds with what individuals want to know in terms of their animals and get a win-win situation that everybody takes part of it. Now, what we want for the next part of the project is we want what we call a maternal part of the resource flock project, because there's a lot of maternal traits that we do not measure well. So we want to follow the females for tree lambings, measure reproduction traits, but also maternal ability and lambing ease and things like that. The other thing, and we want we also want to work with others, like I talked about AWI, but MCA also does sire progeny testing, and they measure a lot of reproduction and wool traits. And so we want to work more with others that invest in data so that it becomes more efficient and it becomes also more equal. So the green bit is basically an expansion that we have in mind for the resource flock. We would have to make more use for the core resource flocks because some become females and others become males. And males are measured still for eating quality, but if your ram goes into this line, it will have both. It will have reproduction plus eating quality. And still we want to work with industry where traits are measured anyway, including organizations like MCA, to see if we can co-invest with them. So I put a very big thing, Strawman model, and I put some numbers that might be not totally correct, but roughly maybe reasonably correct. What the cost of measuring 10 progeny for just those eating quality traits is about $2,700 per ram. The cost of a ram where you also measure those traits, so a maternal sire that wants to know both, would be $6,500 per ram. So you get 10 data on 10 progeny plus 15 progeny for this trait. If you invest in data coming straight from industry, that's often a bit cheaper, but you also measure fewer traits, like you don't have methane and feed intake data and so on, would be a bit less. So the question is, are breeders interested in paying money? And they don't have to pay this money because it still will be a co-investment between levy money and breeders' investment. But the question that we need to ask ourselves, and that's the third point of Ellen that I was supposed to talk about, is I need your help. Or MLA needs your help, I should say. Because MLA has levy money, but they want to maximize the levy money by co-investment. And so if breeders are interested in getting data on their animals, the question is, how much would they be prepared to pay for getting that type of data? And would they be prepared to be part of the project? So this is a question that I need your answers for, and please talk to us and Daniel and so on, to see where your pain points or your opportunity points are. So to conclude, so the resource flock is a key resource for genomic prediction and to select for new traits that we can't measure very easily on our flocks. There's a large industry benefit, and we imagine that in the future also commercial producers will use genomic testing, and that benefits the whole industry, including the breeders themselves. So it's not competition, it's collaboration. The future model for the resource flock will require co-investment and a better way to match what you guys want and what the levy money needs to achieve. And we need to, for that, to explore feasible models where we have a part of data collected on resource flocks, but a lot of data also collected on breeder herds, breeder flocks, and then a good formula how we co-invest in collecting that data and using that for better breeding values. So I think that's my last slide. So basically, that's the question and the discussion point that we need to resolve over time. Thank you, Clara.
Thanks very much, Julius. So we've got time for one question. I think we could probably combine some of these questions around what do we get out of the resource flock, what feedback do we get?
So actually, thanks for that question, because that was a point that I should have mentioned. We have, in the past resource flock projects, done a very poor job on working with people that put semen in. So we haven't given them a lot of feedback on progeny performance. The only thing they got back is better EBVs, or ASBVs, with higher accuracy. And in a way, sometimes it took a while before putting semen in and getting progeny data back in your ASBVs. So, of course, if you have to invest in a resource flock, we should do a much better job on giving you feedback on what your animals have done. So the idea of the next project is also to have a proper team that works more on the commercial side to give feedback to people that invest in them. So I think we've done quite poorly in the past, but that's something that needs to improve.
Thanks very much, Julius.